Hi, this is the first part of the assignment implementing the AI for the NIM game using the Q-learning algorithm. Let's first show how it works. So, NIM is a game with things. Two players take turns removing the items. Whoever takes the last one loses. The entire game and training structure was given to us already, and our task was to implement the learning logic for methods. So, here how it works. So, if we run it, it first training, so it trained by its own tries and figure out how our rules work, what is the best decisions it can make, and what best to do while playing. It has 10,000 games and it trained based on that. So we get the pile, so for example 3, and we take 7 from third pile. It AI take 3 from pile 2. So now we have second pile. I will took 1. Then AI turn. So I will take also from 2 1. And I will lose because AI just left 1. So here is how it worked. So first method that we need to implement it in NIM AI, it's get Q value. So here the AI store all knowledge in a dictionary called self Q here. So the key is a pair, the game state and the action. The value is a number showing how good that move is. So if the AI hasn't seen the situation before, we return 0. We convert the list to a tuple because list can be used as a dictionary keys. So here tuple. Then we implement method update Q value here. We updating the Q value, and this is the heart of our algorithm. The formula is simple. We have new value based on the old plus alpha multiplies by new estimate minus old. So new estimate is the current reward plus the best AI expects in the future. Alpha, it 0.5 means the AI updates its opinion halfway each time. If a move led to a win, reward is 1. If it's loss, minus 1. Here formula. So next, it's a method called bet future reward and choose action here. So third method, we look at all possible move and from the current position take the maximum Q value. This is what the AI expects to gain in the future. First, it's a choose action here. This is a greedy strategy with 10% probability the AI makes a random move with exploration. In the other 90%, it picks the best move from the Q table. This prevents the AI from getting stuck on the same moves. Here how it implemented. We return max, actions, key, lambda. So the next our part of assignment is this one. So we was asked to create a data set. The data set was created by using Python. 40 students here, 8 features: study, hours, sleep, phone usage, attendance, assignment, competition, stress, social activity, and pass grades. The final score is calculated by a formula: more studying, higher score; more phone, lower score. If score is above 50, pass, otherwise fails. So how in our university. So here is our CSV file that was generated, and here how it was generated. Then we have KNN cell. It's a key nearest neighbors. To predict a new student result, the algorithm finds the 3 most similar students from the training set and votes by majority. So we added a normalization. Without it, accuracy was only 58%. Because attendance percentage, large numbers from 50 to 100 was overpowering sleep hours, numbers from 4 to 9. Minimax scalar bring all feature to the range 0 to 1. So here let's run the code. Student 29, accuracy 42, neighbor, distance, and prediction fail, actual fail. So it goes right. Then linear regression. Run it also here. So linear regression predict a specific score, a number. The model finds a coefficient for each feature. So how much the score changes is if that feature increased by 1 unit. So look at the coefficients. Study hour per day has a coefficient of about 6. It's the most influential feature. Each extra hour of studying adds 6 points. Phone usage hours -3. Each hour of phone use take away 3 points. Positive coefficient feature helps. Negative it hurts. So here most influence study hours per day, and here's the calculation. It's a k-means. So the k-means split students into groups with no labels at all, purely by similarity. We choose K3 because in any classroom you expect 3 groups: strong, average, and bad results. So important, it's the assignment science cluster random number 0, 1, 2. So 0 pure, 1 average, and 2 great. So if we run it, we see 2D visualizations, and X is study hours, Y final score. We see clear clouds. Red group struggling, they don't study, have low scores, green high performers, and orange average in the middle. So this kind of clustering helps the teacher understand the group structure without any manual labeling. The algorithm found these patterns in the data on its own. So here how it realized. We read this file, use k-means from sklearn already implemented algorithms. Take the average score, group names, data fragment, put it in clusters, put it map as here, and give it colors.